All right, today we are diving headfirst into a truly mind-bending idea, one that comes from the theoretical notes of research psychologist Dr. Richard Feeney. We're going to question something so fundamental, so basic to our lives, that most of us never even think to question it: time itself. So let's just jump right into the deep end, shall we? The whole theory we're exploring today hangs on this one single provocative question. What if our experience of past, present, and future isn't some river we're all floating down, but something else entirely? And here it is, the core idea, straight from the source. The proposal is that everything in the universe, everything, from gravity to that ticking clock on your wall, can be explained just by using the properties of space. Time, in this model, isn't the cause of things, it's the result. It all boils down to this really powerful little formula, T equals mm. The thinking goes like this. Because we know the universe is constantly expanding, we perceive that expansion, that space in motion, as the forward arrow of time. It's a total, radical reframing of reality as we know it. Okay, so to really wrap our heads around this grand theory of physics, we have to start somewhere you'd probably never expect, in the world of developmental psychology. Yeah, we're talking about how a child first learns to understand the world. That's right. This huge cosmological model is actually grounded in the pioneering work of Jean Piaget. His observations of how infants and children literally build their mental map of reality, that's the foundation for reimagining the entire universe. It's pretty wild. You see, Piaget showed that we all learn about space in the same exact order. First, we have to physically move through it. Then, we start to internalize those ideas to understand things like area and volume. And finally, only after all that can we think about space in an abstract way. It's a step-by-step construction of reality, and the sequence never changes. And the very first, most important milestone on that journey, it's something called object permanence. Before a baby gets this, if you hide a toy, poof, for them, it's just gone. It has ceased to exist. But once they grasp this concept, they finally understand that there's a stable external world out there. This idea is the psychological bedrock for this entire theory. And this is where the leap from psychology to physics really happens. It's a brilliant comparison. Just like the famous linguist Noam Chomsky proposed we have a language acquisition device hardwired in our brains, Fionn suggests we also have a spatial acquisition device. The idea is we are born pre-wired not just for language, but for understanding space. Okay, so now let's get to the core of the theory and see how this all builds from our innate sense of space into a completely new model of physics, one that might just finally unite the world of the very large with the world of the very small. The theory says that these four simple states are all you need to describe everything. Think about it. Is a piece of space filled with stuff, or is it empty? And is that space moving, or is it just sitting still? That's it. Those are the fundamental building blocks of our entire reality. And what's really cool is that when you arrange these four states in a simple grid, a little 2x2 matrix, their interactions start to generate the very concepts we use to describe the universe, from momentum all the way to singularities. Okay, now look at this, because this is where it all elegantly clicks together. Filled space that's in motion. Well, that's what we call momentum. Filled space that's stationary. That's our old friend, object permanence, from back in the nursery. Empty space that's stationary. The theory says that's a singularity. And now for the big one. Empty space that's in motion, that is time itself. But the model doesn't stop there. Oh no! It suggests that gravity isn't some mysterious force. It's just the geometric interaction between filled space and empty space. And get this, when you combine that psychological concept of object permanence with the physics of a singularity, what do you get? A black hole. So what would the cosmos actually look like if this is right? If time is just an effect of expanding empty space. Let's zoom way out and explore the profound cosmic consequences of this idea. So if we really try to strip away time as a fundamental dimension, how does that change our picture of the universe? All of a sudden, these huge concepts like black holes and the Big Bang, they take on entirely new meanings. So in this view, black holes aren't the cosmic vacuum cleaners we imagine. They're actually cosmic anchors. They represent stationary space, and they act as a sort of drag on the universe's expansion, preventing the whole thing from just flying apart uncontrollably. And the claims just get bigger and bigger from there. This model suggests the universe cycles through big bangs and big collapses over and over again. And other realities, they might exist, but not alongside ours in some kind of multiverse. No, they exist one after the other in a grand cosmic sequence. And really, this is the theory's ultimate ambition. It's the holy grail of physics, right? By getting rid of time, which acts so differently at the cosmic scale versus the quantum scale, this theory tries to create a unified framework, a way to finally connect Einstein's relativity with the totally bizarre world of quantum physics. All right, let's bring this grand cosmic theory all the way back down to Earth, back to where we started, with how we perceive things, and what all this means for you and me, right here, right now. And this is where we come full circle. We started this whole journey with a baby learning that a toy still exists even when it's hidden. We end it by asking if one of the most fundamental parts of our own existence, the very flow of time, is also just a concept we've constructed rather than a reality we actually live in. In the end, the author himself brings this incredibly abstract idea back to a deeply human place. Because, let's face it, no matter how we define it, whether we call it time or space in motion, our own personal journey through it is finite. Call it whatever you want, none of us are getting off this ride early. So we're left with this one last, really powerful question from the author. Is our perception of a straight line from the past, through the present, to the future, just a convenient story we tell ourselves, a story to make sense of a reality that is far more random, strange, and non-linear than we could ever possibly imagine? Definitely something to think about.